Good morning, grade 10 students. Today's lesson is about endothermic and exothermic reactions. First, let's talk a little bit about um, chemical reactions. Chemical reactions is when there is a new substance formed and it involves a release or absorption of heat. Before we start our lessons, let's discuss some definitions. We have, for example, chemical energy. What do we mean by chemical energy? Chemical energy is the energy stored in the bonds of a substance. Like, for example, we have methane, and you know methane is a gas that's used as fossil fuel. In methane, um, the bonds of methane, which is made up of carbon and hydrogen, store energy. We call this energy chemical energy. Now, once we burn methane, this chemical energy is transferred from or change from chemical energy into a different form of energy like heat and light. Chemical reaction always involve energy change. Making bonds and breaking bonds involve energy changes. So first, I have to define also in this lesson very important term, activation energy, which is the energy required to break the bonds and the reactants for a chemical reaction. In order to start a reaction, we need to give energy. Have you ever wondered, for example, why if we have fuel and oxygen, why the reaction doesn't start by itself? We need to give an ignition. We need to start a fire. This is because we have to supply the reaction with amount of energy that start the reaction. We call this amount of energy activation energy. Now we have two types of reactions based on the energy. Uh, if energy is released or absorbed, we have exothermic and endothermic reactions. Number one, we said that energy must be supplied to break the chemical bonds. So breaking chemical bonds require energy. Then energy is released when new chemical bonds are made. When new chemical bonds are made, energy is released. A reaction is said to be exothermic if more energy is released than supplied. Yani if the amount of energy released more than energy supplied at the beginning, we call this exothermic reaction. Example about exothermic reaction, when you burn gasoline, for example. Okay, so energy of chemical reaction based on the type of energy change involved. Chemical reaction can be exothermic or endothermic. Exothermic energy is released. Exo means exit, out. Energy is released. Okay, for example, burning of fossil fuel. So when burn fossil fuel, it's exothermic. While endothermic, when energy is absorbed. For example, when you cook pancakes, energy is required for this reaction to happen. Cooking is endothermic because it absorbs the heat. We need to give energy from outside in order to do the reaction. Okay, so let's start first with endothermic reaction. Endothermic reaction, as you can see here, reactants, they have low energy, and we give an energy which is called activation energy to start the reaction to produce a product. You see the products, they have higher energy than the reactant. This means that there is amount of energy which has been absorbed in the process. Okay, so in the thermic reaction, more energy is taken in to break the bonds in the reactants than released by the bonds being formed in the product. Therefore, the energy is absorbed. Okay, the energy is absorbed. So here, the amount of energy is absorbed. We call this a change of energy delta H. We will use in this lesson other form of other than heat, because here the energy is released in the form of heat. We will call it enthalpy. So enthalpy is heat. Enthalpy change in heat before and after. In this case, we have the reactants and the product. You see the products, they have more energy than the reactants. Okay, and delta H is defined as its H of products minus H of reactants. And since here the amount of energy for the product is here, and the amount of energy for the reactant is here. You see delta H of H of product is more than H of reactant, so we'll get delta H is positive. So an endothermic reaction, delta H is more than 0. Okay, so this is endothermic reaction. Endothermic reaction, heat is taken, so temperature drops, products feel cold. Okay, so in endothermic reaction, what happened? The temperature will drop. It will fall down. You see here, temperature falls down in endothermic. Example of endothermic reaction, cold packs. Cold packs, they involve endothermic reaction. Okay, endothermic reaction. Now, endothermic reactions, you may see an endothermic reaction written like this: reactant plus energy give products. Reactant plus heat give products. So energy and heat are the same here because heat is a kind of form of energy. Okay, now let's see exothermic. Exothermic reaction. Here, the reactants, as you can see here, the reactants, they have more energy than the products. So in this case, delta H will be not positive, in this case, negative. So energy is released. Okay, energy is released. So more energy is released when the products were formed than energy was used to break the bond in the reactant. Therefore, a net release of energy. So this is exothermic. So there is release in energy. It's exothermic. In exothermic, as you can see here, we have increase in temperature. The temperature rises. Okay, the temperature here rises. Okay, increase in temperature. So heat is given off, temperature rises, products feel hot, like in the case of burning of fossil fuel. Fossil fuel, we mean gasoline, for example. So exothermic reaction, reacting give product, energy is released. You can see here, energy is released is the form of heat or light. Okay. Okay. So this is the first part of our lesson. We have defined exothermic and endothermic and see the difference between them. Okay. Thank you for watching. I want you to do the assessment questions throughout the lesson.